So hi to all once again. So in the previous video, I have covered in the unit 1, the last topic. I have covered overview of big data, real-time and stream processing. So in this video, as a continuation of that, I'm going to cover the infrastructure of big data, components of big data ecosystem, and goes on. Right, we'll go to that part. So I covered up to this. Now we'll continue. So big data analytics, right, in terms of its usage, right, as we have seen what is big data, what is the need for event processing, what is an event, then what are the components of the real-time processing, everything we've seen, right? So what is the background or technology behind your big data is, for data storage, it is divided into three parts: data storage, data processing, and analytics, right? For data storage, we have Hadoop or HDFS, which is a Hadoop distributed file system. Then Cassandra, Greenplum. For a data processing, Spark, Flink, or maybe Apache is also there. And then Hadoop is there. And for analytics, we have business intelligence, machine learning, and Python. So in this unit, okay, we will be covering only the data storage part. Data processing will be covered in the second unit, and analytics will be covered in the consecutive units, right? So let us continue and see what are the components of this data storage in big data. So the big data ecosystem, if you see the landscape, so much of components are there. If you could see here, vertical apps are there, media apps are there, business intelligence is there, analytics and visualization is very, very important, because dashboards are the famous thing. And we have infrastructure as a service, and then platform as a service, where you have structured databases, operational infrastructure is there, analytics infrastructure is there, data as a service is there. So basically, if you see, all these are the technologies, right, which has been used for the big data landscape. And if you could see, for the analytics and structured databases, we use the Cassandra part, right, and it will be very useful for the big data landscape analysis. So what are the big data ecosystem platforms that are available, such as Hadoop? So this is what we have seen in this part, right? Hadoop HDFS. We'll see one by one what are they. So platforms such as Hadoop and NoSQL, and analytics such as HDB, CDH, EMC, Greenplum, data stacks, and more. Infrastructure such as Teradata, VoltDB, MarkLogic. Infrastructure as a service such as AWS and Azure, right? We all know that Microsoft and Amazon provides it. And structured databases such as Oracle, SQL Server Database 2, and then data as a service such as Inrix, LexisNexis, and Factual. So these are some of the ecosystem components. We'll be seeing one by one. The first is here. If you see the analytics part, right? So I mentioned about your HTTP, CDH, and all. Let us see what are they. So HTTP stands for Hortonworks Data Platform. So what it is used for? It's used for Hadoop-based platform for distributed storage and big data processing, right? Even though the term comes under your analytics, right? First, we have to store it. For that purpose, we are using it. And CDH stands for Cloud Era Distribution, including Apache Hadoop. So Hadoop-based big data platform. That's what is used for. EMC stands for your EMC big data technologies, where enterprise storage happens, right? So enterprise storage and big data infrastructure happens, and this EMC is acquired by your Dell. Greenplum is a database. It supports MPP. We'll be seeing what is MPP in detail in the next slides. Massively parallel processing, right? This is a database for large scale analytics. And data stacks is nothing but it's data stacks or Apache Cassandra ecosystem. It is used for distributed NoSQL database platform based on Cassandra. So here afterwards, we will be talking on Hadoop, NoSQL, Hive, right, and HDFS. These are the components or basic components of big data which we will be dealing with. Then if you could see, I have covered the analytics part, and then infrastructure, Teradata, VoltDB, and we'll see about that also. Teradata is nothing but it's an enterprise analytical database or a data warehouse. It is main purpose large scale analytics. VoltDB is also a database only, right? Very fast it's going to happen. So distributed in memory database. So this will be in your memory database, and very fast transaction or with low latency it should work upon. MarkLogic is multi-model NoSQL database. It's a complex document or data management. Now let us see the infrastructure. So the infrastructure has Hadoop. Hadoop means what? Hadoop means it is distributed framework for data storage. So the word you have to associate with Hadoop is distributed framework for data storage and computation. Hadoop works by distributing the data in chunks over all the nodes in the cluster and then processing the data concurrently on all the nodes. So what we are going to do is distribute the data in chunks in overall all the nodes in a cluster and then process the data concurrently. NoSQL. See, the term NoSQL means NoSQL only. That means we cannot have a structured query in a unmanageable data structure. Huge amount of high volume of data is there. We cannot apply SQL and get a query, and the query to take it out a report will be a huge time consuming process. So that will not be working out here. So that's and it's not the traditional structure also. We cannot use it out here. So it's basically a tool to process huge volume of multi-structured data. So widely known as HBase and Cassandra. They are going to be used. Not a SQL query as usual. SQL query or SQL, maybe SQLite can be used, but SQL query will not be used at all here. Only the huge volume of multi-structured data, the NoSQL based databases called HBase and Cassandra will be used. So unlike your traditional database, they generally have no single point of failure and they are scalable. MPP, I said you to remember, right? So MPP means massively parallel processing. Processes the data at a very fast rate. So when I say Hadoop, the keyword associated is distributed framework, right? The data is divided into chunks and stored in the several nodes. So the basic working uses the concept of segmenting the data into chunks across different nodes in the cluster and then processing the data in parallel. So already in Hadoop, right, we did the same thing. We divided the data into chunks of data and processed the various nodes. Same thing happening here, right? But it does not execute on low-end commodity machines, but it operates on memory. That's the difference between Hadoop and MPP. MPP operates on high-end memory, specialized software. It is not similar to Hadoop. Similar to Hadoop is chunks of data that happens, whereas it processes data in memory. And they have, since in the memory, because of the memory constraints, huge amount of data won't be available there. So light SQL, right? Light SQL can be used as an interface. That's what we have to remember. So unlike your Hadoop that operates at the disk level, whereas your MPP operates at the memory level, right? And it operates upon the collective memory for all the nodes in the cluster. So that's the difference. So that's the difference between Hadoop and your MPP. So as of now, I covered Hadoop, this distributed framework. Then NoSQL, that means SQL cannot be used. We have to use NoSQL databases such as HBase and Cassandra. And then MPP, because very fast transaction should happen. So it is working on the memory level. So these are basically the components of big data. If you could see the layers, right, from processing on the original data, location of our file system, job and task trackers, higher level languages, management and security, modeling, fast loading analytic database, analytic applications are there. So these are basically the analytic big data components. And we have here big cascading Hive, right, data warehouse. If you could see DW stands for data warehouse, Kerberos is for security. And we extract, transform and load and then apply the tools and get the output. And that's what we do here in basically the big data components. So one by one, let us see. If you could see there's a HDFS was there, Hive is there. No? So we'll see one by one. What is HDFS? HDFS stands for Hadoop Distributed File System. And it's a storage layer that handles the storing of data as well as the metadata. Metadata is data of data. NoSQL, because we use HBase and Cassandra, right? It's a key value based column in Cassandra. We cannot use SQL so that we can give a query and wait for huge amount of time to get the data back. It's not possible at all. The computational logic layer can be done also by using a MapReduce. So I have introduced slowly, I'll go through the terms here. I have introduced Hadoop, NoSQL, MPP, then HDFS, again NoSQL here, it just was a repetition, then MapReduce. MapReduce here is nothing but it's a combination of two separate purposes, a mapper and reducer. So the mapper executes first and takes up the raw data set and transforms into another key value data structure. That means basically mapper takes a data set, full amount of data set and try to reduce it, divide into various small groups and have a key value for that. So the reducer kicks in, which takes up the map created by the mapper job as an input and collates and converges it into a smaller data set. Right. So both of them put together. So with the key value only, they, for example, I told in the class that the JKL section students are there. So how do I the whole class, even though it is an RTA students, based on their register numbers, this register belongs to J section, then to K section, L section, like that we can able to have a key value J, K, L, and then map it out, right? Even though the whole raw data set is there, the whole amount of 59 students are there, they can be divided into small data sets based on small groups such as J section, K section, L section, and that JKL is the key value. The next is pig. Pig is basically language, right? It's a high level language. And I told you that in the previous case, Apache, that Storm and Apache Kafka is all using Scala. It has been developed, and this pig is developed, used for writing on the Hadoop, right? To make the Hadoop layer for processing and for conjunction, or as a substitute for a map reduce. This pig is used on the top of your Hadoop, right? Is widely used for creating processing components to analyze very large data set. One of the key aspects is that its structure is amendable to various degrees of parallelism, and it has a compiler that translates pig scripts into map-reduced jobs. So whenever we say pig is a high-level language, right? Various degrees of parallelism. That means various chunks of nodes, or we have various, we divide the whole raw data set into maps and reduces, right? So that job has to be done. For that, we have to implement. This can be implemented based on the pig language only. Then Hive. This is a Hive means I have put a word called DW, data warehouse, right? This is a data warehousing layer that builds on the top of the Hadoop platform. In simple terms, Hive provides a facility to interact with, process, and analyze HDFS data with Hive queries, so which are much very like SQL. So we are going to here provide like SQL, right? That flavor of SQL, but not actually SQL. Why? Because SQL is supported only in MPP, because MPP works on the memory, whereas all others works on the data. We can give that flavor only. So Hive provides that flavor. Hive means data warehouse. That's what we have to remember. So this makes the transition from RDBMS world to Hadoop PCA. So no more RDBMS is used, no more data SQL database is used, only Cassandra is used, right? And that is basically used for your data, because no query, no SQL will be used. Then cascading. This is a framework that exposes a set of data processing APIs. Now we have created a layers, right? The Hadoop layers. On top of it, we have written a language called, used a language called pig, and then we have mapped your mappers and reducers on the top of Hadoop, right? After that, we also should create an abstract layer over the Hadoop, and then we have to cascade all the Hadoop layers over this API layer, so that all will mingle, and then it will all coordinate with each other and work together. Because when we want to use the software, we definitely require an API, and that is the reason. So this cascading is a framework that exposes a set of data processing APIs and other components. It's widely used for application development, because after developing this Hadoop layer or Hadoop framework, it has to be used somewhere as an application, right? For that, we require an API, and that API and this Hadoop can be cascaded using this technique, and that's why we use your cascading logic. Then what are the specialized analytic databases used is, as I already told you, we have used the green plum, the Netiza or the green plum, which has a capability for scaling out and known for very fast data ingestion. Data ingestion means how do we get the input? That means it is a process of gathering the data from different sources and loading into a database, data warehouse or analytics platform for further processing and analysis. So simply if we get the data from one side, right, one source only, that becomes data input, whereas data ingestion is from different sources and loading into a database or a data warehouse where huge amount of data gets stored, right, and then process and analyze the data becomes data ingestion. So this is this database is a mandatory requirement for these ingestions and all. Why? Because normal database will not support it all, right? Because as we are not using SQL also. If, for example, if you could, I could easily make you to understand that books is the data, right? Librarian would be the data ingestion process. That means librarian will collect the book, return the book, or if you want to take it, they will actually scan it and give you the book. And once you return the book, it's library job to put it in the shelves. And the shelves is nothing but data warehouse or database. Library is the person who involves in data ingestion process, because he collects from but the librarian does that, I don't know, from various sources. The librarian collects the books and put for ours. We go take that book, right? That's what is happening. So this is what is basically the big data analytics architecture. So as of now, we have seen what is the big data ecosystem, the big data components. Now it is the architecture. If you could see, there are so many components I have listed up here, whereas it is divided into six, 1, 2, 3, 4, 5, 6 parts. If you could see at the bottom, business solution, what and all is happening, and for data set selection, what is happening, data processing, analytics execution, solution implementation, and ongoing program. And this is what, in a nutshell, I could give you. If you could see business solution, technical process building, business solution building, business process, because big data analytics is always business oriented, right? And if you have data set collection, we have to collect from various sources. That's what I told, not one source. So data 1, data 2, data 3, about third party, another data. So many data sources from where which we collected. That's called data ingestion. As a part of data processing, we have to entity. If you could see, the first part is data extraction and restructuring, then filtering, integrating, transforming, and entity deriving. These are the basic data processing steps. And after that, we have to apply some analytics and see in the output. Then analytics execution. Once you create an analytics, then this can be executed in multiple statistical techniques, what if, what to scenarios, optimization techniques, then go through a workbench and data source manager. Then finally a solution. That means you have come up with a solution for with the big data, whatever it's available, you customize it and give it as a models to whichever applications needed out. So the business solution building, that's the first step. Then data set processing, then automated solution, then machine analysis and optimization. So these are the basic big data analytics architecture, and these are the components available inside that. The last part is distributed batch processing. So in the starting itself, I've told you in the previous video what is batch processing and what is. So I was talking about distributed batch processing. It is a computing paradigm where the tuples, this is not the tuple as the Python, so this tuple is a record, right? The tuples of the records are batched and then distributed for processing across a cluster of nodes and processing units. You may ask me, ma'am, you told only real-time processing is used, not batch processing, but this uses both. The big data uses both, right? You also use batch processing as well as real-time processing. So the tuples of records are batched and then distributed for processing across a cluster of nodes and processing units. So one such node completes the processing of its allocated batch. The results are collated and summarized for the final results. So in today's application, we are used to process a huge amount of data and get results at a very fast and speed, right? And it is beyond the capability of a single node does this process. Not possible, right? For that only, we have to have a very good machine. For example, we can improvise the machine through its computation. For example, we can add more compute capability to a single node, or we can add more number of nodes to perform the task. So let us see what is this one. So there's two types of scaling is there, vertical scaling and horizontal scaling. Vertical scaling is a paradigm where we add more compute. That means compute is nothing but more CPUs and more RAMs can be introduced to an existing node to replace it so that we can have a very powerful machine. Or this model also works well, to some extent, right? Whereas if it's hit the ceiling, for example, we have put 16 crores and then RAM as 32 GB, but still if we use more amount of data and then more number of clusters are developed, in that case, if it's hit the ceiling, we cannot work upon it. So if we depend on only one node, there's a chance for single point of failure. Okay. So to avoid this one, we can go for horizontal scaling, right? This relies on clustering where multiple nodes are used. And the computation capability is basically not derived from a single node, but from a collection of nodes. So in this paradigm, the model is scalable and there is no single point of failure. So how does this distributed database works is through NoSQL. It is because again here it is not working on memory, it is working on system, so data, right? So this distributed database is a database where there's no single control unit or storage unit. It's basically a cluster of homogeneous or heterogeneous nodes, and the data and the control for execution orchestration is distributed across all nodes in the cluster. So very one important thing is this distributed nodes can exist both physically or virtually, right? We all know that we have used the virtual machines, right? The same concept. So what is this use of your NoSQL is, there are two things is there: replication, duplication is there, right? We'll see one by one. It is tracked by a special component of distributed database. This piece of software does the tedious job of bookkeeping for all the updates. See, if you could see here, normally in cloud, what we'll do, we'll go for replication of data, right? All our Gmail accounts are replica and kept somewhere on in the servers, right? Maybe 3 times it will replicated. But why? Because we talked about there's no single point of failure because we kept in various nodes, and similarly we should have replica of data so that at no point there will be a failure, right? For all the updations, additions, deletions, everything gets updated in the replica of data. Right? What is a duplication is the popularity of distributed database is due to the fact that they don't have a single point failure. So there is always more than one copy of your data. So replication and duplication is goes together. Duplication is you have your data duplicate. Replication is whatever, when you duplicate it, whatever actual data happens for that, right? That has to be replicated there, right? That's what is the basic difference between replication and duplication. So replication means you have to replicate whatever actions performed on the data. Duplicate means we have 3 copies or 4 copies of data all over the servers, all over the world. It may not be in one place. It may be in a distributed fashion. It is available. So that is the reason we are able to support with NoSQL database, because different cluster of nodes, very immediately we can get out. In one cluster to get out the data, for example, in one node to get out the data is very difficult. So the advantage of NoSQL databases: advent and growth of big data, high availability systems, location independence, and schema-less data models. How to choose a NoSQL database is based on input data diversity, scalability, performance, availability, cost, stability, and community. Right? These are basically the advantages in choosing a NoSQL database. So thank you. I have covered all the components which are necessary for a big data, starting from here. If you could see, I'll just give you a nutshell. So we have talked about overview of big data, real-time and stream processing, infrastructure of big data, components of big data ecosystem, analytics architecture, distributed batch processing, and distributed databases with NoSQL. So thank you. The Unit-1 video is covered in all this. And I think I have covered through 3 videos. So watch out and learn the topics. Thank you.